Catch this. Notice this formula says the probability of A or B says add this, and subtract the intersection. So if I'd asked you for the probability of getting a 4 or a queen, notice that you see that there's 4 queens, so you say 4 out of 52, and then you would add 4 out of 52. Are there any intersections between these two cards?
2. I don't know.
No.
No, in other words, are any of the cards the same?
No.
The 4s are all just 4s. That makes it 8 out of 52, and that's why most of you would logically say there's 8 out of 52 chances. Now watch this. If I'm just going to change it a little bit, what if I'd asked you the probability of getting a heart or a queen? A heart. How many hearts are there in the deck?
12.
No.
13. No.
52 divided by 4.
9. No.
Might have presented a bigger problem.
13.
13 is correct.
That's what I said.
As long as I find them all, we'll see it.
That's what I said.
But in reality, there.
All right, let's see if I've got 12 here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hearts, but technically 13. Let's do the math again. Now check this out. If somebody had asked me what's the probability of a heart or a queen, I would think logically. I'd say, well, there are 4 queens and there are 13 hearts. But do you see that they share a card in common? You know? Who said no?
I said yeah.
Yeah. Good. Yeah. This here is the Queen of Hearts is in common, so that's kind of important to see with the math, and that's what this formula is telling you. It says, okay, what's the probability of getting a queen? And you say, well, yeah, it's 4 out of 52. It says, well, what's the chances of getting a heart? And you say, well, there's 13 of them. 13 out of 52. The only problem is, do you realize that I just counted this card twice? That's why it says, please subtract the intersection, in other words, where they have something in common, once. And now I'll be able to get the probability that you would get by you simply seeing it here. But this is very visual. You can see that I was adding the same card twice. And so therefore, if I know there's an intersection, I must subtract it once because I've technically added it twice. So everybody kind of catch that. And that's a very, you don't get, if this is like the one thing you get from this section, at least you walk away with something very, very important. That's a very important skill to kind of understand and know. Now, that formula is very popular. It's in every textbook. Please know. All right, here we go. Moving on. Now they're going to get into this whole idea of about this word independence and dependent. And they get into this symbol here. And I'm kind of curious if you guys know what this symbol means. Or the answer to that question, but does anybody know what this might mean?